So before we move on to the technical stuff, I have made some visual representation of our implementation. So the requirement of this problem statement was to build an optimization AI and migrate past Excel data into a robust database environment, and that's exactly what we did. So we set up a front end using React framework. Think of front end like a dashboard of a car. It shows you all the important information at a glance and lets you interact with the system easily, right? So it's similar to that. It's actually the user interface from where you can access the whole application. And for storing data, we used PostgreSQL. I think that database is self-explanatory. It's where all our data lives. But to fetch the data from the front end and properly populate the database, actually need something called a server. So a server acts like the brain of a system. It handles and compiles everything internally. So we actually proposed two servers, like a person having two brains. This is because AI models are resource heavy and it takes a lot of time to compile. By isolating the AI models on their dedicated server, the main server can operate freely without being slowed down actually. And in this flow, you can see that the front end doesn't need to worry about making connection to multiple servers because all the routing are made only through the main server. For example, if the front end need to access some routes in the AI dedicated server, the front end will actually make a request to the main server, and the main server will forward the request to the AI server, and once the AI server gives a response, it will be forwarded to the front end. So by doing this, our application will be robust and it can save time and resources. So now let's dive into the technical stuff. So to create and train an AI model, we need data sets, and data sets are essential for teaching the models to recognize patterns and then optimize operations. However, we faced a problem. We couldn't find any operational data sets for sale, as we all know that they're confidential. So using the data available from the official government website, let me show that. Yeah, from this data.gov.in, we collected all the available data, and from this data, we generated synthetic logs that closely resembles real-world operations. Now, I'll show you how that's done, how we created a synthetic generator and made our synthetic logs. So what we have done is we actually created a simulation to generate synthetic logs because real world transparent data isn't available. The only data we could fetch is the annual total like coal used or steel exported and so on. So with that limited data, we first built a plant simulation system where multiple plants work together to produce the steel quantity we provide. For example, say if the target is 10 million tons, the plant log generates day-by-day production across the year. And coal and limestone consumption will stay within the limits. So let me run and show you the plant log generator now. So it's running now. So it's asking for the total coal used in a year. So from data, what we got is 12 million tons and then 6 million tons of limestone and 10 million tons of steel exported. So after this data, you can see that plant log.xlsx is being generated. So we chose Excel file as the export because in the problem statement we saw that Sale is already using the Excel format. So you can see that synthetic logs has been generated according to data that we have given. So if we sum up all these, the final amount we get is, yeah, you can see that 10 million. So this is how it also works for the coal and limestone. So everything is in control. No extra steel has been added or missed. The exact amount is being calculated from the generator, train log generator. So now instead of running each and every generator one by one, let me use the master generator here and let me run everything in one go. All the whole thing of mention and then run the field. So when the comparison runs, you can see now plant log generator has been generated now, and then next up the train log generator will be generated. So in the meantime, let's see what we have implemented in the train log generator. Creates a simulation of train log, carrying coal to plants from local sources and ports, and trains carrying steel from plants and ports for export. Each train journey time is calculated from distance and average speed with random delays for realism. And then departure and arrival timing are fully synchronized with the plant log. If a plant exports steel at a certain time, the train log shows the corresponding departure at that moment. And if coal delivers or deliveries are similarly synchronized with the plant data. So the train log is derived from the plant data, and the transport cost is calculated per kilometer, and the mass balance is also maintained. For example, no extra coal or limestone or steel appears or disappears. So it is completely synchronized with the plant data. And then similarly, the port log. It tracks daily port operation using train log data. So every train delivering steel is reflected as an incoming cargo, and vessels are randomly assigned berthing times, loading durations, and capacities while keeping total steel exported consistent. So and then coal and limestone imports are handled in the same way too. And we also have a weather delay index, which shows random slowdowns. And the port log gives a realistic day-by-day record of cargo arrival, shipments, and storage utilization. And after these, we have this vessel cost generator. It will generate the cost of every vessels that are being used, and then vessel delay history. So it generates random delays in the vessel docking time and demurrage time, those and all. And then we have a port tariff generator. So the tariff is kind of fixed. It is initially generated in dollars, and then we have converted it to rupees. So plant log here, you can see the train log here. So yeah, you can see the rake ID, material flow, material source and destination, and the total time taken, departure, arrival, and how much cost it's taking, and port handling charges, and the total trip cost. So similarly, we have these other Excel files also generated. So in the port log, you can see the necessary details that has been generated here. So it is a simulation. Everything is synchronized. For example, the plant is the initial generator. From that, everything is literally synchronized, so that the data integrity is maintained here, and the cost of vessels here. So everything is generated. So we took this much time to implement this is because for model creation, the data sets are very really important. So as we didn't have any original log, so we have synthetically generated, but it is not very far from real world application. It is very similar to how data logs will be generated in real world. All right. So I definitely know that the synthetic generated part was a bit boring. I don't want to bore you even more. So let's jump into something more exciting. So now let's run our React application and along with both our servers and see everything in action. So let me run our front end first. And in other terminal, let me run my main server. Python. Okay. This is just a warning, it's not an error. It's a warning that it is a development server and do not use it in a production deployment. And so in another terminal, let us run our AI server. All right. So it's a warning regarding to the version mismatch with the TensorFlow package. So nothing to worry about. So you can see it's active now. It's running actively. So I'm calling the main runner file outside the package. I mean the servers. Let me minimize it. Yeah, it is in the root level. And then I'm calling this runner file, and then it's calling the server, and it's from the init. Inside I have a init folder. So as I give it init, so then it's converted into class instance kind of. So and then it's calling the server. I'll show you how we can inject Excel data directly through the front end and how it gets automatically populated into our PostgreSQL. And not just that, I'll also show you how we can trigger AI model training right from the front end itself. It's going to be fun. Let's take a look. Uh, let's open our front end. Yeah, so this is how our front end is going to look. Visually appealing. The data are gonna be populated into more visually appealing way. And it's just the data that we synthetically generated. The same data is being shown here. And let me show the optimization at last. Okay, now let's go to the data management section. I think we can go with the AI model training as it will take a long time to run it. So when I click on training, you can see the status here. Now it's running. You can see it over here. Yeah, you can see that the neurons are being trained one by one. After the completion of first model, the second model will be trained. When I click on the button, it will call a route which is in the main server, and then the main server will forward the request to the main server. So it will be getting these AI routes. Here you can see trigger training, right? So it will call the trigger training function, and then it will trigger the running of those two training script files in a thread. And then after once the file is trained, it will be saved into the AI models. So you can see there are already two models has been trained, and when this file gets trained, in this model gets trained, it will be replaced by that. Inside training scripts, we will call the database to fetch the data directly from the database. It will fetch the latest data, and then you can see that we have used relative pathing to make the compiled file to save into AI models, and similarly it's been done to the other file. So let it run, and now we'll go with the Excel injection. And the status here is being pulled every 3 seconds. We have another route defined over there. You can see training status, right? So whenever the application calls this route, the get training status function will be called, and then it will return the status of that thread. Let me show it to you. So you can see I am calling my localhost port 5000 is my main server. From the main server, it will be forwarded to the AI server. So in this route, in this API endpoint, you can see that it is returning a value, and this value is being shown in the front end. Okay, so now let's go to the Excel injection. Before that, let me show you my database. So I'm using pgadmin to access my PostgreSQL server. You can see that I have a database created, holistic optimizer, and schema inside tables. You can see I have initialized 6 tables. Okay, so let me show you what's inside um, data slash. 1 minute, I forgot the schema what I have gave inside models. Yeah, I have give it as tariffs, data slash tariffs, and if I get it, you can see it is returning a empty data because there isn't any log that has been pushed into this tariffs. Other tables are already populated, but this I have left it empty because I need to show how the Excel injection works. So let us go to the front end, and here we'll select port tariffs, and then select the Excel file port tariffs, and then we'll be choosing that. As you can see that it's running, and the localhost says Excel uploaded successfully. And then if we go to this, and I can check if the data has been successfully updated or not. So yeah, now you can see that the Excel files data has been successfully uploaded to the database using Excel injection. Okay, now let's go to this thing. I think our model has been successfully run. Let me check in our server log. Yeah, here you can see that training port delay finished successfully, model training complete. So now my team Saranraj will explain more on how our model works.
Yeah, let's see about AI model. We created two AI model, one for port, one for delay. We created with Python TensorFlow library. We requesting database for data. Before processing the data, we need to converting and standardize it. Here it's a part where AI model analyze and find pattern in our data, and it save our model in .keras format. We created separate function which to predict train and port delay. Here first of all we need to load our AI model .keras file. After we need to standardize our input passed by given by our user, and using dot predict function we need to pass our input through that AI model. It will return our prediction.
Now my teammate will explain the implementation of AWS and how we'll migrate to AWS once we have completed our development phase of our application.
Hi, this is Alvindias. I do AWS for this project. In the initial stage, we started building and testing our project locally. We created a local host Flask server for our backend and used a local PostgreSQL database to store and manage all our datasets. This local environment helped us to train our AI model, test our optimizer logic, and ensure that all the models were working perfectly before moving to the cloud. Once the local version was successfully tested, we decided to migrate our system to AWS for better performance, scalability, and we created an EC2 instance in AWS. In the instance is currently running in state. If the instance is running, they shows the public address. We also create a PostgreSQL in the AWS, and currently we added 3 security groups for this PostgreSQL after we migrate to it.
Thanks for being patient. We are eagerly waiting to work with the real data set sooner. Thank you.